primary gateway, secondary gateway, super gateway, SaaS gateway, partner gateway, NVS gateway. Confused yet? So let's take it step by step. First of all, the gateways are hosted by VMware, so they'll be responsible for patching them, keeping them up to date, securing them, and scaling them. Secondly, any edge you deploy today will automatically connect to a primary and a secondary gateway, and it does that based on distance. So when an edge boots based on its primary IP address, we'll be able to geolocate them and assign the closest gateway that will act as a primary gateway. And then we also select a secondary or backup gateway, not in obviously the same points of presence, but about 50 or 60 miles apart. The primary use of these gateways will be to support the routing function. So the gateway becomes a controller. Every new edge that comes up will register to the gateway, and it's the gateway's responsibility to tell the rest of the estate that the edge is live and also what local area networks it supports. In this case, it acts just like a BGP route reflector. So what happens if two edges don't actually share the same gateways? Because I might have edges in Europe, I might have edges in the US. Based on the location, I'll have totally different gateways. And this is where the concept of super gateway comes in, because every enterprise will have a primary and a secondary super gateway, and it's the device of last resort. So now if you want the edges in Europe to communicate to the ones in the US, it's the super gateway's responsibility to make that happen. Leaving the control function aside, you can optionally use the gateway to route traffic between sites. So if, for example, you might not have a data center locally, somewhere to install that hub. If you remember the last video, we spoke about the hub and spoke topology. You can then use the gateway as such. And it gets even better, because with the gateways, we now can achieve a much more elegant cloud on-ramp. So by default, when we route between SD-WAN enabled sites, we can build the overlays and we can track their performance and make a decision based on that. How can we do that if the traffic is destined for the internet? Certain solutions implement an IPSLA type of functionality in order to understand the health of the underlay. However, with the gateway, you can achieve this much quicker. Also, if you're doing any sort of VPN to a non-VeloCloud site, whatever that is, to get traffic to security solutions such as Zscaler or connecting to legacy data centers, you can do that through the gateway. So it actually saves you time from connecting each of those branches individually.